Hey guys, we are back to 7.2, the second PowerPoint talking about holes and hole notes. So we're going to talk about the different types of holes that you can find that we're going to be annotating in our drawings. So there are a number of different holes, about 6 of them we're going to chat about. So the first one we have is called a through hole, and this is just referring to the depth of the hole. In this case, the hole goes all the way through your object, so if we were actually looking, we could see completely through, and they're annotated with just that THRU. The second one we have is a clearance hole, which is wide enough to allow the entire screw head to pass all the way through it. Third, here we have a blind hole, which just essentially means that the hole stops before it reaches the other side, so you can't see it on the back side. Now we go on to our countersinks. In a countersink hole, this means that the top of the hole has an angle to it so that the head of the screw can be below the surface of the material. So the entire head is going to be down in here, so this will be a flush, even surface. And they are typically used with tap screws, so there's going to be threading in this hole. After that, we've got a counter bore. And again, a counter bore has a recess around the top to allow the head of the screw or the bolt to be flush underneath the surface. And it is just a circular hole with straight edges instead of the angled as a counter bore are. And then the last one we're going to talk about is a tapped hole. And again, as I mentioned earlier, that just means that the hole has threads already cut in it so that the fastener can screw in even better. Now let's look at some of the annotations that you're going to see on drawing files. So you guys are familiar with the diameter symbol, and that's just the circle with the slash through it. Your counter bore looks like this kind of very wide, well, I guess a square without a top on it. Countersink has the V, and then this little symbol here is indicating how deep something is. So all of these are going to be used in our annotations. And we'll just look at some annotations here. So any hole annotation is going to have a number of different pieces of information. Let's learn how to read them. The first thing you're going to have is a diameter. So first off, it's going to tell you how big around the hole is. And then typically right behind that, you're going to have the depth indicated. In this case, it's telling us that we have a depth of 0.75. If this was going all the way through, we wouldn't have that symbol. It would just say THRU, indicating that the hole goes all the way through. On this particular example, we are also being told that this is a counter bore. That's what this symbol right here means, that it's a counter bore. And it's telling you that the counter bore portion has a different diameter and a different height. So in this case, we are looking at, if we were to cut this sideways, it would be a hole shaped kind of like this. Excuse my rough drawing here. So this section right here, all right, that is the counter bore section, and it is being specified on this second line. So it's saying that it's going to be 0.38 wide and 0.25 deep, where this top section is telling us that the hole that goes down even further, it goes down 3/4 of an inch, is only 1/4 of an inch deep. So this information right here is for this portion of the hole, whereas this information at the top is for this lower bit in our description. So that's that one right there. Let's look at some of the others. On this particular one, we just have a nice blind hole. Nothing special about it. It's only 0.38 inches in diameter. There, it's said right there, and it's 1/2 inch deep. Very, very simple. We're going to keep going here. Here we have another one that is 0.38 inch in diameter, and it goes all the way through. So this would be a hole that would go all the way through. So if we looked at these from a side view, come on, this one is just going to be a nice straight hole that would go all the way through. This one here would be a hole that would only go part the way through. So if we were looking at a section view, which you'll learn about in a minute, from the side view, we'd have 1, that has a hole that goes all the way through, another one that has a hole that only goes part of the way through. This one over here was our counter bore, so whoops, it would go like this, or it would be wider. All right, so those are just some really rough drawings. And let's see, where do we go next? Now we're going to show you a little bit more specifics here. It's just more examples. This particular one is talking about a countersink. So we've got the angle. Again, if we're looking at it from the side, it is going to have, I'll draw it right here. It is going to have an angle to it coming in before it straightens out. And it's telling you the first number is reading how large or what the diameter of the bottom portion is and how far down it goes. And then this section right here is telling us, hey, this is a counter bore, and the counter bore top is 1 inch in diameter. So that would be this circle right here. And it has an angle of 82 degrees. So we're talking about this angle right here. If we were looking at it from the side, be the same as this angle right here. Okay. And I know right now you're probably going, how am I going to annotate all of this? Luckily, Inventor does a lot of this for you. I just need you to understand how to read them. Alrighty, let's keep going. Now, thread notes are specified using one of two methods. We're either going to use the Unified National Thread Method, which is UNC for short, or the ISO, the International Standards Organization. Now, if you guys remember, in the United States, we use both metric and we use the English or imperial system. UNC is imperial. ISO tends to be metric. And just keep that in mind as we move through this. So here's an example of a specified type of thread note using UNC or ISO notations. So here it's telling you we have a 5/16 inch diameter. So it's actually given it to us in a fraction because, like, think about it. You're trying to drill a hole. Remember, all the sizes that we have, they're all in fractions. So it's 5/16. Then the second number is telling us how many threads there are per inch. And then the UN is Unified National Standards. And the C, in this case, it means coarse threads. Sometimes it's UNF for fine threads. So this is just a standard agreed upon set of measurements. It's pre-built into Inventor. If you guys remember when we made holes, we did a drop down on this and we chose some of these options. This is one way to see that annotation. Let's look at the next one. Here we're looking at some ISO, and again it is a specified excuse me guys, specified set. We're starting out, it's telling us, hey, this is metric. It's telling us the diameter because remember, metric system is very convenient. It's all in millimeters. So in this case, it's just saying, hey, it's 12 millimeters. It's telling us the pitch of the threads. And then it goes on to some other specifics based on the tolerances of the hole. So you'll get these other numbers talking about the grade and the threads and the allowance. And then lastly, we have the through indicating that it goes through. Now, right now, I know you're all going, oh my gosh, this is so much information. What the heck am I going to do with it? I'm going to pause this and go over to Inventor and show you how you actually do this in Inventor. Okay, guys, what I've got here is a block with a bunch of different types of holes in it, and we're going to talk about how to actually annotate these. So if I want to annotate holes, it means I need to make a new drawing file. So if remember, we're going to go to File, New, and my pop-ups over here. I am going to always choose the curly title block, which I have installed on my computer. All right, let's call this Hole Practice. I'm going to put in my name, which I always spell wrong. This is sheet number 1, and I'm not sure what my scale is going to be yet, so I'm going to leave that blank. And it's going to create this nice whole practice with practice spelt wrong. All right, so I'm going to place my base, and just because I'm showing you how to do holes, that's all I'm going to put on here. I'm going to make this about 2 to 1 and call that a day. Okay, so here I have my holes, and you can see I've got 5 different types of holes here, and I want to annotate them. So we're just going to go to annotate, and I'm going to choose this hole and thread option. And now when I click on my hole, I just clicked on the edge and drag out. It does all the annotations for me. So you see when I hover over it, it turns the outer ring of the hole red. It changes my mouse from an arrow to a cross with another little annotation there. And I am just going to click and drag. And I just click and drag. Remember, we don't want to have our leader line straight on holes. So that's it. Super easy. You just need to remember to follow the dimensioning rules about the placement of those holes. Try not to cross lines. Try to keep them where they're supposed to be, not on the outside. I'm just throwing this up here so you can have a quick look at it. So it's very, very simple. If you have any questions, let me know. Have a great one.